Hello, for Data Communications and Network 1 class today, my name is Usna Chantulaves from Kasetsart University. For this clip, we will talk about communication system models. Communication system model. I will start with the most simplified, okay, very simplified model first, okay. Basically, I have source, okay, and transmitter. Source will generate the data, okay. Transmitter is the one who transmit the signal. This is transmit signal, okay. And then I have receivers, okay, who receive the signal, and destination is the user who will use the signal, the data, okay, who you want to send to. So we basically have three parts: the transmitter part, or the transmitter side, the receiver side, and the transmission system, okay, in the middle. Okay, let's look at an examples. Transmission system can be a network, okay. The network can be like local area network, LAN, local area network, okay. It can be internet, okay, internet, okay. It can also be point to point if you have source and directly connected to destination. This can be point to point link. Okay, it's a point to point link. Okay, so transmission system can be many things. Okay, and this is you divide it into basically three parts: transmitter, receiver, and the transmission system. Now let's look at the model with signals. Okay, the model is still simple, but I add the signals information into the diagram. So I have, suppose I want to send text, okay, like A, B, C, D, 1, 2, 3, okay. This is input information M, okay. Then the source, okay, this is still very basic. So let's say the source generate the digital bit stream, okay, like this, maybe 0, 1, 0, 1, okay, and it's become waveform like this. So this is the data in terms of time domain signals, okay. If you transmit directly like from the keyboard, suppose you input your text into the keyboard, okay, you can just type in the keyboard ABCD, okay, without changing it into the waveform, okay. So it depends on the application and on the source and transmitter. Anyway, for this case, okay, the transmitter usually will modulate the signal, okay, modulate the signal so that it can be transmitted in the bandwidth that we want, okay. So usually it's sent in terms of analog signals, okay. But this analog signal is modulated like usually in the digital communications we use digital modulation, okay. I'll talk more about this in the next slide, okay. So this is the transmitted signal ST, okay. Then you go through the transmission system like networks, okay, or point-to-point links, can be wired or wireless, okay. Then you receive the signal RT. The signal is usually have noise added to it. So suppose you have ST look like this, okay. You add noise, you will get something look like this. So this is RT, okay. Then the receiver has to make decision, okay, what RT means, okay, in terms of digital bit stream. So it's make this, so this one look like this, okay, and it make decision and get the digital bit stream like this. The destination, so this is G prime T, okay. We want GT and G prime T to be the same, okay, and we want M and M prime to be the same, okay. From the G prime T, the destination will decide what is M prime, okay. The decision is sometimes made in the receiver, sometimes it's made in the before the destination, okay, because this is very simplified models, okay. Usually they have many boxes in between. Anyway, we want M prime, okay, to be the same as M, and want G prime T to be the same as GT. But I have to write as G prime T or M prime because sometimes it's not the same. Okay, because of the noise, okay, sometimes you make a wrong decision and what you receive is not the same as what you transmit. But you want to reduce the difference as much as possible. You want to receive the correct thing, the same thing, okay? Now let's look at the more detailed models, okay, of the data communication systems, okay? You have source. So source can be, suppose it's my voice. So it may be analog signal like this, okay, time domain, analog signal, okay. Then you have A to D. A to D is analog to digital converter, okay. This one we will talk about in detail later on. So you change the analog signal to digital signal, okay, data to digital signal. If it's already digital data, you don't have to do this, okay. Then you have the data compression. Data compression is you make it efficient, okay. You make it efficient by, okay, suppose you want to send like this, A, okay, B, A, okay. So instead of doing this, you may change it, okay, into A5, B2, A4, something like this. So you change with fewer numbers of characters, okay. So you compress the data, okay, to make it use less resource, okay, to transmit because it's become a shorter sequence, okay. And then you have data formatting. Data format, so you format the data in the form that is good, okay, for your applications. And then you have binary, so this one become binary sequence like this. And then so from this, okay, you may convert into binary sequence, you format the data. Then data framing, packetizing, adding header. What is this? This is like when you have 1101 like this, okay. You put it, this is your data. You put it into a frame by adding header here. So you have a header here, okay, and this become a frame. Okay, sometimes you have to add tailor in the back also, but sometimes you don't, okay. So this is a frame. So you add header so that you can like do something with it, okay. In terms of formatting, in terms of telling the other side, okay, what is your rules or what is your data compression technique, something like that, okay. Then you do modulation. As I told you before, like for digital modulation, you have ASK, amplitude, chip keying. You have like PSK, FSK, okay. This is phase shift keying, and then frequency shift keying, okay. So this is you changing the parameters of the carrier signals, okay, in order to represent the baseband signal. So you modulate into the higher frequency. Again, we'll talk about this a lot later on, okay. Then this becomes electromagnetic signals, okay, waveform, maybe look like this, okay. Then you send to the channels, okay, channels or links or networks, okay. The technical term is like channels. Then you receive electromagnetic signal which may have noise, okay, it may have noise like this, okay. And then you demodulate it. You demodulate it, and then you get something like this, okay, like frame, okay. Then you depacketizing. Depacketizing means you take only the data out, and you throw away the header. You read the information in the header and you use it and then throw away. So you can take the data out, and then you do the error detection and correction. Detect if there is any errors and correct if there is some errors, okay. So these are two techniques to make sure that it's reliable communications. Then you get binary sequence here. Hopefully that is the same. And then you do the data interpretation. You interpret what it is, okay? Like it become like this, okay? And then you do the data decompression. Change it into A5 of A, B, and then A, something like this. This is decompression. And then change it to voice. I mean, if it's voice, it's A to D before, okay? But if it's not, you don't have to do this one, okay? So basically you get the original whether information back, whether it's a voice or whether it's information like this, okay? So this is it, okay? This is just some simple explanations, okay? When you study higher and higher, you get more and more blocks here, okay, to add some like encryption and stuff to your data, okay? And so anyway, this is the end of the clip, okay? Thank you very much.